So what kind of predictors are we going to look at, or what kind of tasks, what kind of prediction tasks will we cover in this course? We'll basically cover three. We'll cover classification, we'll cover regression, and we'll cover clustering tasks. So I'm going to show them kind of pictorially just to get everyone warmed up. So in classification, what do you have? You have a collection of individuals, so these are maybe the people that we've seen before, and they are represented in some way. And in a classification task, in addition to this collection of individuals, somebody comes along and gives us some labels for some of these individuals, right? So he says that maybe this one is an F, and this one is an M, and this one is an F. Okay? Now, as a learning algorithm, you actually have no idea what those labels mean. Right? And you really have no idea what these things are. Right? But somebody comes along and attaches some labels to some data points. So what does a classification algorithm try to do in a situation like that? What it tries to do is it builds that predictor. And in classification, the predictor takes on a particularly simple or reduced form. So the whole predictor takes the form of something that we call a decision boundary. Right? So a decision boundary is an imaginary line that goes through our space or surface, and it cuts the space into two parts. So one part is going to be the part where our algorithm thinks the M's live, and the other part is where the F's live. So what it tries to do is it tries to draw a boundary in the space of data points such that all the F's are on one side and all the M's are on another side. So that's what it tries to do. That's what the decision boundary is, and it's a fundamental concept in classification. And we're actually going to dwell quite a bit on what decision boundaries are and what form, what do they look like geometrically for the different learning algorithms. But that'll come in a few lectures. That'll come a few lectures down the line. So for now, you just have some sort of a decision boundary. M's on one side, F's on the other side. So this red line is the function. That's it. There's nothing more to it. That is your predictor. And how does it predict stuff? Well, if you fall on one side of the boundary, it will predict an M for you. And if you fall on another side, it'll predict an F. Right? So maybe M is the market going up and F is the market going down. Or maybe M is the individual is male and F is the individual is female. So you've just built a predictor to detect gender based on whatever however you represent that individual. Okay, so that's classification. Now, the important thing to keep in mind is this classification, this decision boundary only looks that way because of the labels we put in the data. So we could take exactly the same data set, exactly the same set of individuals, put some different labels, maybe a couple of yeses and a no, and what you hope for is that your learning algorithm will produce a different predictor, a different decision boundary. So maybe this decision boundary reflects whether you're going to loan money to that particular individual or not. So you had some examples of people who paid up. You had an example of a person who didn't pay up. So that's how you decide to draw the boundary. And again, the function, the predictor, is just the decision boundary, nothing else. That's all. So the prediction is which side of the boundary you're falling on. So that's classification.